So to begin, we're going to start with a right triangle. And you can see here the two legs are length 4 and length 5, which makes the hypotenuse approximately 6.4. The next thing we're going to do is we're going to create a circle that has the center A and that goes through C. So all points on this circle are 4 units away from A. So then we're going to just create an arbitrary point on this circle and then construct a new triangle. Now it's ADB. So the things that are constant between ABC and ABD are that they each have two sides that are the same length, 4. AD is also 4 because they're both radii of the circle. And then they also have this side that's 5. So the question now is, what happens to this other length, BD and BC, as I move D around the circle? So let's measure BD, which you can see here, which is 4.91. And then as I move D around the circle, you can see when it's exactly at point C, we're at 6.4. And that's when the triangles are congruent and that angle at point A is a right angle. Now if I move it a little bit to the right and make that angle smaller than 90 degrees, you can see that DB shrinks and it gets smaller than CB. And then if I move it a little bit to the left, the angle gets bigger than 90 or it becomes obtuse, and now the opposite side length is bigger than what it was if it was a right angle. So we're going to use this property to determine or to classify a triangle as being right, acute, or obtuse only given the side lengths. So how are we going to do this? If I have a triangle that has the following 3 side lengths, and I want to classify it, I need to compare it to the Pythagorean theorem. Because let's assume for a second that it's a right triangle. The 2 smallest sides would be the legs. And then the question is the hypotenuse going to be 6? So let's check. So if this was a right triangle with legs 3 and 4, the hypotenuse would have to be 5. But in our triangle, that third side is 6. So it's not a right triangle. And if we think about the last graphic, in order for this to be 6 and this to stay 3, this angle here would have to be bigger than a right angle. So that would make this triangle obtuse. So we could do it this way each time, or we could find more of a systematic way of doing that. And that's by using the converse of the Pythagorean theorem, which I'm going to do for the second problem. So let's say I had the following side lengths. I had 4, 8, and 10. Instead of solving for x, I'm just going to test the Pythagorean theorem by squaring each one of these and putting it into the Pythagorean theorem and seeing if it's equal. So I'm going to take the 2 smallest side lengths, square them and add them together, and then check whether or not it's equal to the largest side length squared. So 4 squared is 16, 8 squared is 64, and 10 squared is 100. And then I'm going to add these two together and I get 80. And now, is 80 equal to 100? No. So it's definitely not right. So now the question is it obtuse or is it acute? Well, is this side too big or too small? And if you look here, the 10 squared is much larger than the sum of the 2 sides, the 2 smaller sides squared, which means that that angle is going to have to accommodate by getting bigger. So if this side is too big than what it should be, if it were a right triangle, that makes it obtuse. So let's just summarize so that we have something to check by. If a squared plus b squared equals c squared, then it's right. If a squared plus b squared is smaller than c squared, meaning c is too large for it to be right, then that opposite angle has to be obtuse. And then finally, if a squared plus b squared is, larger than c squared, meaning c is too small for it to be a right triangle, then that angle must be acute. And that triangle also must be acute. So one more thing, a and b, when we plug them into the Pythagorean theorem and check, must be the smallest sides.